Hey guys, welcome to my channel. I'm GD Coder. If you guys are new to my channel, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty great problem today, so let's read the prompt statement, right? So it says, given the root of a binary tree, right, return these zigzag level order traversal of its nodes values, right, from left to right and then from right to left, right? For the next level, and you alternate between them, right? So right now, initially you go left to right, and then you go right to left, and then you go left to right again, right? That's pretty much what they're saying. So we keep alternating between the two way that we can go, right? Left to right and right to left. What I'm saying. So yeah, we kind of simulate a zigzag shape. What I'm saying. That's where the name comes from, zigzag. What I'm saying. So yeah, guys, so this is very similar to a problem that I did before that, right? It was called level order traversal, right? It only had that, right, in there, level order. So there was no zigzag. So it was boundary tree, level order traversal. So if you guys haven't seen that question yet, I'm going to leave a link so you guys could probably go ahead and check it out, right? It'll give you a bit of an overview of how we're going to go about solving this problem, right? This problem is very similar, and the way we're going to solve it, guys, you'll see it's almost exactly the same code, right? They're actually using the same picture. That's how similar they are, guys. I'm saying, yeah, they got the same verbiage, everything. So now the way we're gonna go about approaching that problem, guys, we're gonna have a we know that it's gonna be a breadth first search, right? Because we're gonna traverse the tree level by level, and there's no better way of doing this than doing it breadth first search manner, right? It's a very good technique to utilize for this particular problem, guys. You know what I'm saying? So now, guys, how can we? So now the way we're gonna go about solving it, right? So now how we're gonna go? So initially, we first start right, we go left to right, right? So there's a long back, and then we're gonna go right to left, right? So now the trick is, right, the way we're gonna do it, right? So we know how to go from left to right, right? We just add the numbers. So let's say we were going left to right for this level, right, from 9 to 20, right? We will simply do 9, we visit 9, right? And then we visit 20, and we just add 20 to the end, right? The end, right? To now we know that the numbers for that particular row is 9 and 20. That's perfectly fine, right? Now, let's say we want to go right to left, right? Now the trick, right? Where we're gonna go about solving that problem, guys, we're gonna, you know, to simulate that we're gonna go from right to left, right? We're gonna process the thing the same way, right? But to give them the illusion that we're going from right to left, as we're processing the numbers, right? When we're supposed to be going right to left, we're gonna add 9, right? Same thing, we're gonna visit 9 first. And then now, instead of adding 20 to the end, right? We add it at the beginning, guys. What I'm saying? Yeah, to give them the illusion that this is how where we went to right to left, but we really processed the nodes from left to right. But instead of adding the numbers, no, the regular way, right? We adding stuff to the list, we add them at the end, right? So we just keep appending to the output list. But no, but instead of adding it to the end, we add it to the beginning, right? And we ship everything over. I'm saying, and so we can do that in Java. So we just put the numbers at index 0, and then it shifts every number that comes after at this particular index and after it uh, towards the end, right? So that's how we're gonna solve this problem, guys. You know what I'm saying? So let's go ahead with the implementation, guys. So right now we know first things first, right? If a root is null, right? For root is null, we're gonna return a empty list, right? Now, guys, after we do that, we're gonna have the queue, right? The queue as promised. So it's gonna be a pure tree node. So new linked list to get the linked list implementation, right? So after we do that, guys, we're going to have have our output list, right? As you guys can see, this is very similar to the other problem, guys. Extremely. So they just changed the constraints a little bit, and then that made it a new problem, I'm saying. But if you guys really understood the other problem, this problem should be pretty easy, guys, I'm saying. So now, guys, once we get the output list and we get the queue, right? The queue is going to help us do the breadth first search, right? That's why we have a queue, right? So now, pretty standard in every breadth first search problem. So now we add the root, right, to the queue, right? So we can start doing the breadth first search algorithm, right? So now we're gonna do while the there's still node to be processed, right? While the queue's not empty, right? Still nodes to be processed. We're going to take the snapshot of the size of the level, right? Because we're gonna visit, because we're gonna do things level by level. So we're gonna take a snapshot of the current size, you know what I'm saying? So we take a snapshot of that by doing the queue.size, right? Before we start processing any node, we take the size of that level, you know what I'm saying? So initially we add 3, right? The 3, right? So now we take a snapshot. We know there's only one node in that level. So any node we end up adding to the queue, right, is not going to count towards that level, you know what I'm saying? Because we know there's only one node in that level, you know what I'm saying? So yeah, guys, the next thing that we're going to do, right, we're going to have the temporary, we have the temporary list, right? So we're going to call level list, all right? Level list, and then URL list, right? So now this is the list that's gonna, the temporary list that's gonna help us in building that temporary list so we can add it to the output list, right? Because every level needs to have its own list, right? So that's why we have that right now. So now, guys, we're gonna have the for loop, right? So the for loop is gonna help us iterate through all the nodes for that particular level, you know what I'm saying? So now we're gonna go up to level that size, right? When we take a snapshot of it, so we don't lose track of it, right? So we're able to control the how many times it goes to. So now we're gonna iterate through all the nodes in that level. So now we're gonna process one node at a time, right? So now we do node, right? So we take one node out of the queue, right? Queue that poll. So we take that out. So after we take that node out of the queue, right? So now the next thing that we need to do, right? We need to check which way are we going, right? Are we going from left to right or right to left? So the way that we're gonna end up doing that, right? We're gonna do the level, right? So we know the first level is 1, right? So we're gonna do level 1, right? And that variable is gonna help us, guys, you know, and to determine how we're gonna go, right? Are we gonna go left, or we're gonna go left to right, or right to left? So we're gonna so yeah, guys, we're gonna check level, the level, right? The particular level that we're on, right? So this is level 1, level 2, level 3, right? So now we know that if a level, right, is odd, right? If a level is odd, then we know we're going left to right. Because we're going left to right from this level. We're going left to right at that level, right? Because they're odd, right? So now, easy. So if we're going from left to right, right, we could simply add the numbers, right, to the add the number to the output to the temporal that we have. Right? So no that val, right? So now, if we're going right to left, right? Remember the trick that I told you guys? So we do the same thing, level the list. But now we add the numbers to the beginning, right? So we do 9, right? And then we do 20, but 20 gets added to the beginning to simulate that we're going from right to left. So all the numbers that's on the right side, right, that comes after are actually going to be at the beginning, you know what I'm saying? So yeah, guys, so we put the 0 to make sure that we add that number to the beginning, right? And then everything that comes after it gets shifted over. So we would add 9, right? 9 will be at the first at the beginning, right? And then now once we get to 20, 20 gets added to the beginning, and then you shift 9 over. You know what I'm saying? Say, all right, 20 is the captain now. 20 is at the beginning now. So yeah. So now, so we just know that about, right? Make that off a bit. All right, cool. So now that we have that, guys, we're pretty much in good shape. So now we just continue the same other code that we have in the other problem, right? So we check no that val. None of that val. It's no that left, right? It's not null. Right? We add it to the queue, right? Add the left to the queue, right? So now we need to check the right as well, right? Now right's not null. We add it to the queue as well, right? Add it to the queue, right? Yeah, so yeah, guys, now the next thing that we need to take care of, right? We need to add the temporal list that we built for that particular level, right? Because for every level, we're gonna create a new list, right? for every level, right? Every time we start over. So now we need to add it to that output list that we're building. You know what I'm saying? So we add that in there, right? And then now, guys, remember, we need to, every time we process a level, we need to do level plus plus, right? To go on to the, to tell it that, you know, this is, there's going to be another level that we're going to go into. So that's why we increment the level plus plus variable, right? So after after we process 3, right? We 3, right? We're done with this level. So now we're going to that level, right? We need to increment the level variable so that we know which way to go. Are we going to go from left to right or right to left? So now level initially is equal to 1, right? And then we done processing 3, right? We now level goes to 2 now, and now 2 is even. So 2 is not going to be odd. So now 2 is going to use this way of adding numbers to the temporal list, right? So that's why we increment the level variable, and that's why we have that, guys. I'm saying. So let's just check, see if we passed that small test case. Perfect. Let's see if we pass all the test cases. Awesome, guys. We're able to pass all the test cases. I want to thank you guys for taking the time to watch this video. Let me know in the comment section if I did a pretty good job at explaining the problem to you guys, you know. And also, if you guys have any concerns, just let me know. Yeah, if you guys are new here, make sure to subscribe because I do other videos just like this one. And yeah, I want to thank you guys for watching. Yeah, and I'll see you guys in the next video.